We saw in the previous section about the potential of multimodal language models. However, we really haven't figured it all out yet. Multimodal language models are not immune from LLM limitations. In fact, they inherit a lot of the same risks. First is hallucination. You can see over here on the right image, this is output by the Flamingo model, where it completely hallucinates what is in the image. For instance, when asked what is the message, what is on the phone screen, the Flamingo output says a text message from a friend. The other LLM limitations like prompt sensitivity or context limit and inference compute costs all apply to few-shot learning cases for multimodal language models as well. Unsurprisingly, it also inherits the same concerns for bias and also toxicity. For instance, this is one of the latest examples that we see on the internet where an Asian woman asked a model to make her photo more professional, but it made her photo more white. And what is interesting is that this model that the company has used uses fine-tuned on Stable Diffusion model and basically uses the best possible open source text image dataset out there, which is Leon. So it's very likely that this problem is not unique to this particular company. And of course, we also have all sorts of copyright issues as well. Just like for Leon, they don't claim any ownership over their copyrighted images. A similar concern or question also arises for Reddit as well, since we have been using Reddit dataset to train a lot of large language models. And back in March or April, they also posed this question that they want to get paid for helping to teach big AI systems. Multimodal language models can also lack common sense as well, where we ask models to generate some image based on text, the output can be completely nonsensical. And you can also see that we see the same problem with LLMs as well. When we ask GPT-3 to complete this prompt, something about cranberry juice, but you have a bad cold, but now GPT-3 says that you should drink it, but you will be dead. So what's the next thing that we'll build to improve upon our existing models? It's possible that a lot of these challenges will be really hard to resolve and might never go away, but there are alternative architectures that we can consider other than the attention mechanism. Attention, and particularly self-attention, has been the focal point of the field in NLP and even for the field of computer vision. But it looks like there are actually other existing or emerging promising contender architectures. I won't cover the nitty-gritty about all of the architectures. My goal here is to bring them into your attention because who knows what might stick. So first, let's talk about what might remain and become an integral part of every application. It is none other than RLHF, which stands for Reinforcement Learning with Human Feedback. No matter how good models get, perhaps the best way to build a reliable model in production is to always involve humans in the loop. Here, the human feedback is used to train the reward model. And the reward model is typically another language model that outputs a label, or a ranking, or a score that is preferred by a human. On the other hand, there is also KL loss to ensure that the fine-tuned model doesn't diverge too much from the original pre-trained model. So this reward model would encode human preference and assigns a quality label to the model output. Finally, the proximal policy optimization, abbreviated as PPO, the algorithm will update the pre-trained large language model based on the reward signal. This is a really huge topic on its own, so I encourage you to read about this topic in your own time. Now, let's talk about the possible next in architecture. It's called hyena hierarchy. It uses convolutional neural networks rather than transformers or attention mechanism. And the researchers found that it makes a pretty good few-shot model for languages, and it also matches the performance of vision transformers. So maybe CNNs will be making a comeback. The second architecture that has gained quite a bit of coverage in an NLP newsletters these days is retentive networks. The authors propose a new variant of attention, which is retention mechanism. This retention mechanism can connect both recurrence and attention. But what is special about this mechanism is that it is able to achieve higher computational efficiency without compromising model performance. And this is typically a really tough challenge to crack. How do you have good model performance without it being too slow, and vice versa? So lastly, I want to wrap up this section by highlighting a variety of emerging applications in the field of multimodal language models. I'll see you in the last video.